for our project, we made a manometer, came empiricus call it, for fluid mechanics. So the purpose of a manometer is it measures space compared to the atmosphere outside. It does this by using piezometric pressure head and water displacement in the vertical direction, changing the height of water, or some other substance, usually depending on how high you want it to go. So the materials we used we used a plastic pitcher for the container. The bike pump was used to add pressure. PVC vinyl tubing was stretched up high to actually get the manometer apart. The plastic pipe fitting was to connect the pitcher to the PVC vinyl tubing. The metal clamp, make sure the connection was secure. And then we used plastic bonding glue everywhere to make sure that there was no pressure leaks. Okay, so this is our setup. We used the bike pump and we connected it to the plastic pitcher on top, as well as a pressure gauge. It's not very accurate, but we had to have some form of reading. And then we used the glue, as you can see, all throughout here on the gauge and everything. Here's the plastic pipe fitting. We drilled a hole in the side of the pitcher, and then glued the pipe fitting on there. Then attached the vinyl tubing, and then put the metal clamp on. And that was how we made our project.
So here's our experiment. We got the bike pump, and we got the pitcher with the pressure gauge on it, and we got the vinyl tube going up about 9 feet. And Chris and I marked out the centimeters on the tube. Can't really see that in the video, but it's there. So now we're going to start and apply pressure, and the water levels are the same right now, meaning that the pressure inside of the container is at an equilibrium with the atmospheric pressure. Let's apply pressure. As you can see, the water level is going to rise when I apply pressure. The reason it's fluctuating is because I have to keep letting off of the bike pump to put in more air.
The change in height is right around 257.
257?
Yeah, 257.
All right, cool.
Okay, so during the experiment portion of this project, we found that the change in height of the water in the tube was 257 centimeters, and the change in height in the tank was 2.5 centimeters. So here you can see the manometer drawing right here. So we have the pressure in coming from the tank, and that's going to be equivalent to the pressure of the container, or coming from the bike pump, sorry. And so when we pipe in pressure, we're going to have a change in height of the water in the tank. It's going to go down, and we're going to have a change in height of the water in the tube. It's going to go up. So that's represented by delta H little t, delta H big T. And we also have pressure from the atmosphere coming in through the tube. So right here, we just got our basic hydrostatic and, piezometric pressure. So we have the pressure of the container right here equal to the pressure of the atmosphere plus the change in height of delta HT and delta H big T. So we add these two times the gamma of water. And so pressure of the atmosphere is just going to be 0 because it's gauge. And the pressure of the container is going to be equal to the gamma of water times the change in height of the container plus the change in height of the tube. And so what we get is we get the pressure of the container after we plug in all the numbers and we change it from centimeters to meters. We get 25.43 kilopascals gauge, which is 3.7 psi gauge. Now the actual pressure gauge on the tank is not very accurate, but it kind of fluctuated around this 3 mark. So we're just going to say that it's pretty good.
All right, and after we're done with the manometer, you can actually use it to water your plants. See? It doubles in purpose.